Okay, so last lesson, right? Last lesson, we talked a little bit about something called, remember? Prime numbers. All right, if you can still recall. All right, so we talked about something called prime numbers. All right, and I did give you and one of the the other student, a little task. All right, so this was the question that happens the last week. So let me just give you a quick recap of what's the meaning of prime numbers. All right, last lesson I told you that the most important word for the lesson is called prime. And what does the meaning of prime means? All right, so prime numbers actually has only has two factors. All right, prime numbers only has two factors. And inside the two factor, one of them must be a 1. And the other one is itself. All right, what do I mean? So for example, the number 2. All right, so people ask you, hey, what are the factors of 2? You can say it's 1 times 2. All right, and one of them is a 1, it's a definite 1, and the other one is itself. All right, so it concludes, right? Concludes. All right, next time if you see 3 dots, right, Asfa, if you see 3 dots like this, right, these 3 dots actually means in conclusion. All right, in conclusion or therefore. Okay, so you can see 3 dots like that, 3 dots, it means that therefore or in conclusion, the number 2 is a prime number. All right, because it only has 2 factors. And I told you to memorize, right? I told you to memorize the most important thing about the prime numbers. The examples are 2, 3, 5, 7, and 11. These are the first 5 prime numbers that you have to remember. All right, so this was from last week's lesson. Okay, and I told you about things like the test on divisibility and all this. Those are good to know using your mental calculation, using a fast way to get to the idea if a number can be divisible or not. That's good. All right, but the most important thing is still about prime numbers. And I love math. All right, I love math because of one reason, right? Because that's the opposite. So opposite of prime numbers, right? Opposite of prime numbers is something called composite number. All right, opposite of prime number is something called composite number. It's just like what we have. We have something like odd, and the opposite is even, right? We have positive. The opposite is negative. Right? So there's always this opposite effect. Times, opposite is a divide. Plus, opposite is a minus. Right? So this is like opposites. So mathematics, there's always these 2 different direction. That's the reason why I like about mathematics, because it's very fair. Okay, same. All right, prime numbers opposite is called composite numbers. And if prime numbers only has 2 factors, what's the meaning of composite numbers? Composite numbers will have more than 2 factors. More than 2 factors. All right. So if you take a look at the example down here, we have 2, 3, 5, 7, 11. So the gap in front here, example is a 4. All right. Things that is not prime is composite. All right, so 4 belongs to here. 5 is the prime, 6 belongs to here. 7 is prime, 8, 9, 10 belongs here. Can you see? And 12 and so on. Okay, so 13 will be a prime. All right, 14 will be a composite. So more than 2 factors means what? For example, 4. 4 is made up of 1 times 4 and 2 times 2. So the factors are actually, we don't repeat the 2, we write it as 1, 2, 4. So there are 3 factors, right? So that makes it a composite number. How about 10? 10, we have 1 times 10, 2 times 5. So the factors of 10 consists of 1, 2, 5, and 10. So there are 4 factors. So that makes it a composite number. The very, very special very, very special, that is not prime and not composite. The very, very special number that is not prime and composite is the number 1. Right. So number 1 is, we call it like a neutral number. Right. 1 is neutral. It's not here, not there. Neutral. Not here, not there. All right. So the number 1 is not here, not there. Must remember that. It's neither prime nor composite. Right. So it's not prime and not composite. So in strictly speaking, right? Strictly speaking, there are 3 groups. Right? Strictly speaking, there are 3 groups. 1 is a neutral number. It's not a prime. It's not a composite. It's by itself. We have prime numbers whereby there's only 2 factors. Right? The examples are 2, 3, 5, 7, 11. And if numbers that are not prime are composite. So we have those in between numbers like 4, 6, 8, 9, 10. All right. So all these are actually composite numbers. All right. So this is what we covered the previous week. So here we have these 4 numbers here. Determine whether the following numbers are prime or composite. All right. So we can just use our calculator to try and error a little bit. Right. 103, the 3, right, is a odd number. So cannot divide by 2. All right. How about divide by 3? Cannot. Because divide by 3, I told you about the test of divisibility. You have to add the digits. 1 plus 3 is a 4. 4 is not a multiple of 3. Can we divide by 4? No. Because divide by 4, the last 2 digits have to be a multiple of 4, right? Remember? Cannot divide by 5 because the last digit must be either a 5 or 0. Divide by 6? No. Divide by 7? Maybe. Can we try divide by 7? Right, so you press your calculator, 7, 107, 103 divided by 7. What does it give you? 103 divided by 7? Nope. Right. It must give me a whole number. It cannot be like a decimal. 7 cannot, 8 cannot, 9. 9 cannot also because we don't have the cannot divide by 9. The sum of digits cannot divide by 9. 10 cannot. 11. 103 divided by 11. Nope. 13. Nope. 14. 15. Nope. So this is actually what I call a prime number. Right, a prime number. Okay, right, because the only possibility is like 1 times 103. That's all. All right, so 1 is a 1 and the other one is itself. That's called a prime number. Sometimes you ask, Cher, when do you stop? You just now try to divide by 7. Then you try to divide by 11. Then you can try to divide by 13. Try to divide by 17. Can we try to divide by 17? You know, cannot. Like, I mean, when do we stop? When do we stop trying? All right, so sometimes if you have that question in mind, right, that's a good question, just to let you know. All right, because I was taking 103 just now, right? I was taking 103 to divide by 2, 3, 5, 7, 11, 13, 17. I try to divide by the prime numbers, yeah. All right, but when do I stop? When do I stop? All right, so you stop only when you look at this number. 103, right? If you do a square root of 103. All right, in primary 6, right, you learn this symbol, the square root. Where do you see this before? For example, they give you a square. Right, they give you a square. And they tell you that the area, of this square is, let's say, 16 cm square. And the question asks you to find one side. Have you seen this kind of question before? So it must be the same length. So you take a square root of 16 to give you a 4. So one side of the square is 4 cm. All right, so that is what you're trying to do down here. You take the square root of 103. It's actually 10 point something. 10.1488. It's not a nice number, I know. But it gives you a direction. It gives you an idea when to stop. So can you see that 10, all right, is actually very close to what? It's very close to 7 and 11. So actually, I'll stop at 11. It's good enough. All right, so that is a guide. That's just a guideline to tell you when to stop. So you don't have to divide by 13, don't have to divide by 17 and all this. All right, let's see whether this rule works or not for all the numbers. Let's try question B. All right, so number B, this one is an even number. This is an odd number. All right, so 229, right? 229 cannot divide by 2. Can you divide by 3? Let's try. 9 plus 2, 9, 10, 11, 12, 13. Cannot. All right, the sum of the digit add up to 13. 13 is not a multiple of 3, cannot. Can you divide by 5? Cannot, because 5 must be 0 or 10. Can you divide by 7? Okay, let's try. 229 divided by 7. Cannot. Okay, can it be divided by 11? 229 divided by 11? Cannot. But when do we stop? Do we stop at 11? Okay, so use that method. 229, right? You try to find out what is the square root. What is the square root of 229? Right, you can press your calculator. Square root of 229 is equal to 15.132745. So you must work your way until it is close to 15. All right. So after you divide by 11, what's the next number? Let's try divide by 13. Let's see whether 13 works or not. 229 divided by 13? No. After 13 is 17. All right. 17 is quite close to 15 also. What? All right. So 229 divided by 17? No, it doesn't work. All right. So if it doesn't work, right, you stop there. You stop down there. All right. So 15 is very close to what? These two, 13 and 17. So you try these two actually. All right. So it doesn't work, you stop down there. All right. So 10 is for 11 and 7. All right. So you don't go and try 19 anymore. All right. 19 is the next prime number. Okay. So that's the idea. All right. That's the idea. So in this case, right, if there's nothing works, right, conclude that this is a prime number. All right. There's only 1 times 229. How about 161? Okay, let's try. All right. So 161, right, is down here is once again is an odd number. Okay, so cannot divide by 2. Cannot divide by 2. So 161 cannot divide by 2. Divide by 3, 6, 7, 8 cannot. The sum of digit is 8. 8 cannot divide by 3. After that is 5. 5 is a 0 or a 5, but it's not. It's neither as the last digit cannot. Divide by 7. Maybe let's try. 161 divided by 7. Yes, it works. Woo! It works. All right, 7, it works. Very good. So once you know that one of the number works, right, you can actually list out 1 times 161. All right, 7 times 23. Ta-da! All right, so there are 4 factors. There are 4 factors which makes this a composite. All right, so that is the idea. That is the guideline. All right, so if you still want to carry on a little bit, right, to test out, all right, when to stop, once again, you can use this method. All right, this is the trick behind. Seldom your teacher teach you one. Because sometimes they don't know when to stop. And students are asking, teacher, when to stop? All right, but they don't know how to answer. So you take the square root of 161 is around 12.688577. All right, so it must be close to 12. It must be close to 12. All right, so you can actually try up to, after 7, you can try 11 and 13. All right, but you have to stop there already. All right, don't go on. All right, don't have to try 17. All right, you can stop at 13 because 12 is between 11 and 13. All right, but in any way, we got the 7 already. 7 is actually part of the factor of 161. All right, can you understand? Can I? Yeah. So all these little tips, right, Asfa, right, all these little tips, right, that I'm writing on top, right, all these, you can actually write back into your exercise book. All these are tricks that your teacher seldom teach you. Okay, so I think it's important. And since you're here, of course, I must give you some extra things. All right. So once again, the 817, the 7 is not a even number. So it cannot divide by 2. Can it divide by 3? Let's say 8 plus 1, 9. 9, 10, 11, 12, 13, 14, 15, 16. Cannot divide by 3 because the sum of digits is not a multiple of 3. Can it divide by 5? Cannot because it's not a 0 or a 10. Can it divide by 7? All right, let's try 7. 817 divided by 7. Nope, cannot. Can it be divided by 11? Let's try 11. 817 divided by 11. Nope, cannot. After that is 13. 817 divided by 13. Cannot. Hey, sure, where do I stop? When do I stop? Very good question. So when do you stop? right? Because it seems cannot, what? But 817 is a big number, all right? 817 is a big number. You need to